Thank you for the introduction. And also, I would like to thank the organizers for giving me this opportunity to sharing. This is a new preprint available at Archive. This is a joint work with Winnie Lee at Penn State and my colleague from Team 2. And so, let's see. Okay. So basically, what I'm going to talk about is in the framework of hypergeometric functions. There are special functions satisfy a lot of symmetries. And there are many existing formulas, including Clausen formula and Whipple's formula. And in the past few years, basically my interest has been kind of interpret these formulas over finite fields in a systematic manner and use them to solve open problems. For this talk, the particular motivation is to construct decomposable hypergeometric motif, which according to a conjecture of David Roberts, Fernando Rodriguez Villegas, will give a connection to the subject, the so-called subject of supercongruence. And the formula, the particular formula I'm going to talk about will be this Whipple's formula. So it's actually going to be a formula relating two hypergeometric values. On the left-hand side, so it's a 7F6. 7 means there are 7 upper parameters. And 6 here means there's a 1 by default and 6 other parameters on the left-hand side, and the argument is 1. And Whipple's formula says, if you compute this hypergeometric value, it will be the same as 4F3, while on the right-hand side, you only need 4 upper parameters and 3 lower parameters, and the argument is also 1. And you will need a gamma factor to make both hand sides to be the same. And this formula will actually valid when both hand side terminates, means one of the upper parameters to be a negative integer. So it's instead of an infinite sum, it's going to be a finite sum. So that's the case when both hand side terminates. So this actually is a pretty kind of useful formula. I used it a few times before. And what I'm going to use it today is to interpret this formula under additional assumption called the primitive and self-due. And then we're going to identify the decomposition behind Whipple's formula on the level of Galois representation. Consequently, we obtain a list of decomposable hypergeometric Galois representations. So which is the end of my elevator pitch.